Okay, everybody, in today's lesson, we're going to be starting on the topic of density and pressure. I'm going to be teaching you this topic from scratch, okay? In this topic, we have a lot of formulas. So if your math is weak, and it shouldn't be weak, especially if you're my student, mathematics should be your strength. Formulas should be your strength. Rearranging should be your strength, right? So this topic does have a lot of formulas, but you'll be fine. Just like with electricity, you're fine. All right? So density and pressure. This topic is super fun, by the way. I really enjoyed it, and I'm sure you guys will too. So what is density? What is pressure? For now, don't be overwhelmed with all this stuff. Just ignore it. Just concentrate on me for now. What is density? What is pressure? So, first of all, and you might want to write this down. In fact, don't take any notes for now. Just watch me. Density, the formula for density is rho is equal to mass over volume. I know it says P, but that is actually pronounced as rho. Okay? Not to be confused with the formula for pressure. Pressure is equal to the force over the area. Now, we'll get into units in just a second, because is the mass measured in kilograms? What is it measured in? What is the volume measured in? Right? Okay? We'll talk about that in a little bit. I don't want to concentrate on units. Just want to tell you these are the formulas that you need to know right now. And it will help you understand what density and pressure is. So the formula here is for density. And it's rho, don't say P, it's pronounced rho. The P in the density formula is pronounced rho. So P is equal to the mass over the volume. And the P here is actually for pressure. And pressure is equal to the force over the area. Rather than memorizing these formulas, I want to explain to you. I want to explain to you what density is, and I want to explain to you what pressure is. Density is how much mass there is in a given volume, hence mass over volume. So how much mass there is per volume. So suppose you have a balloon, right? I'm not the best at drawing. We can get Google images, but we all know what a balloon looks like. So just pretend that's a balloon. And this is in fact, no, what we'll do, we'll compare a basketball and a bowling ball, right? So in this case, just stay with me. A basketball and a bowling ball in my world is the same size. Yeah, so they're identical. Which one's heavier? Which one has more mass? The basketball, the bowling ball? The bowling ball. And it's because the bowling ball has more particles. It's made up of more stuff, more mass inside. Right? It has more stuff. Obviously, the particles don't look like this, but I'm sure you appreciate what I'm saying. So because it's a solid, those particles do not look like a solid. So let's do an actual, let's do the arrangement of a solid. So particles in a solid look like this. They're jam-packed together. They're nice, neat rows, and so on, so on, so on. Right? And there's loads of them. Right? There's loads of particles here. So that's the bowling ball. Whereas the basketball just has a few particles and it's gas and they're all spread apart. So what I'm trying to say, density, how dense an object is, it depends on how much mass there is in a given volume. So you can think of the volume, which volume basically means space. So both the basketball and the bowling ball has the same space inside. But the bowling ball is much more dense, hence why it's heavier as well. Does everybody understand that? So does everybody understand why the formula for density is mass for a given volume? Yeah? Does anybody not understand that? Yeah, it's easy, right? So it's mass per volume. Now, this is that's cool, whatever. We kind of know that already. But pressure, oh man. Pressure, the formula for pressure is super fun. It's super fun. to understand at least. I want everyone to do an experiment, right? Everyone look this way. I should turn on the lights, but I guess there's enough light right now. Get your fingers, everybody. In fact, no. We'll start off with the palm. Get your palm and apply some pressure, apply force to your forearm. Does everybody see what I'm doing? So get your palm, right now, do it with me. Get your palm and apply force onto your forearm like this. Apply force. So push against your forearm. Does it hurt? No, it doesn't even feel uncomfortable. If anything, it feels like a massage, depending on how hard you're doing it. Just do it softly. It feels like a massage, doesn't it? It feels nice. Right? Now, get your finger and apply the same amount of force to the same spot. That hurts. Now, why does that hurt? Why does that hurt? My fingernail, yeah. My fingernail is why it hurts. No. Actually, why it hurts, it's because of pressure. Pressure is equal to the force. Now, both times with both your finger and your palm, you are applying the same force. But the area of your finger is much less. Imal, that still doesn't make sense. Well, let me explain it to you using math. Now, you should know that force is measured in newtons, right? So, for example, if you want to feel like what 1 Newton of force feels like, go get an apple and put it in the palm of your hand. That the force you feel of the apple pushing your hand down is what 1 Newton of force feels like. Okay? And of course, I do talk about this in my earlier videos. You can go watch them. I've done a whole section on just forces. Right? So pressure is equal to force over area. Cool. So let me explain this in math. The pressure you felt with the palm of your hand was equal to the force. Let's say you were applying 3 newtons of force. So like 3 apples, you can kind of say. 3 newtons. In fact, let's pick an easier number because the math will be easier. So imagine the force was 10 newtons. We'll forget the units for now. Over the area of your hand, the area of your palm, let's say it's 5. Don't worry about units, just 5. So what's the pressure? It's equal to 2. If you want to be technical, it will be 2 newtons per meters cubed. Right? It'll be 2. But your finger has a way smaller area. So it's still the same force. I told you to push down on it with the same force. But this time, the area was much smaller. Let's say it was 2. And 10 divided by 2 is equal to 5. You're feeling 5 newtons of force per meters cubed. Oh, per meter squared. I'm so sorry. Area, the unit is centimeters squared, actually. I feel so dumb now, but whatever. Okay, the units are not so important here. Okay, I don't care about the units. All right, I just want you to focus on the numbers. So you see what we had, the smaller the area, the higher the pressure. And that's why a nail can go so easily through a wall. If you look at a nail and hammer, right? The reason why a nail goes straight through that plank, it's because the area is so tiny. And even a little bit of force can push the nail through, can go through wood. Whereas if you put your palm, you've done a light tap on the wood, your palm will never go through. And this concept is so important for you to understand so many things. For example, when you go, I forgot the sport, you know, when you go on the snow, what's that called? When you go skiing, notice, why do they never sink into the snow? Like if they took off their, well, what is this called, man? I'm not that cultured right now. If they take off their skis, if they take off their sleds, or skis, whatever. If they take this off, their feet will sink into the snow. The reason, right? This bit here, they do not sink into the snow. It's because the skis, or whatever it's called, has a large area. It has a large surface area, and that's why they don't sink in. Is that understood, everybody? Here's another example. If you look at a tractor, right? Look at a tractor, not a tractor. There are these different types of tractors. Yeah, look at this. Why do you think the wheels are shaped like that? So just get rid of the formulas for now. Why do you think the wheels are shaped like this? It's because, you know, that tractor is literally like, I don't even know how heavy it is, but it's like in the tons. How heavy is a tractor? It's like this is a small one. This one would easily be like, what, 10 tons or something? That's so much force acting on the that's so much force acting on the ground. Why doesn't the tractor sink into the ground? It's because all that force is being divided by a large area. So look, really understand this. Even if you have, let's say, 100,000 newtons of force, but if that's being divided by 100,000 centimeters squared of area, forget the units for now. What's going to end up happening? It's just going to cancel out. And so on the floor, you're just going to get a pressure of 1 Newton per centimeter cubed, per centimeter squared. Does everybody understand that? Does everybody appreciate what pressure is? Yeah? Now, there's another thing you need to understand about pressure. And this is where it's going to get really fun. Okay? That's one definition of pressure. In physics, pressure could also mean, right? Now bear with me. You really need to concentrate here. Please, everybody listen. You really need to concentrate. In physics, pressure is also the force, right, that particles hit the walls of its container, the sides of its container. That sounded well confusing. Hold on, that was stupid. Look, everybody look at this way. Look this way. I'm specifically referring to gas pressure here, right? But we'll slowly, the more we talk, the more we'll be able to distinguish between the two. We've got atmospheric pressure and all that good stuff. But for now, just listen to me. You know a balloon, when does it pop? When does a balloon pop? It's when there's too much pressure inside its volume. So what are particles? You can imagine, what are particles doing inside the container? They're hitting the walls of its container. They're bouncing everywhere. They're pushing against the wall. Now, if you keep blowing air inside, there'll be more particles and more particles and more particles will be keep hitting the walls of the sides of its container. It's going to be keep hitting the walls of the container, the sides of the walls of the container, until eventually it hits it enough times on one spot that a rupture happens and it pops. Okay? Does everybody understand that? Now, I want to show you something really cool. I want you to really appreciate what pressure is. Suppose you see a bird flying. How does a bird stay flying? How does that even happen? What's the physics behind that? Wings are massive? Maybe. Let's look at a wing of a bird when flying. Yeah? Let's see. What is going on? Why does a bird always go like this? In fact, this is a beautiful picture. How does this owl stay flying? Now, you need to understand there are two things happening to this owl right now. There are particles underneath its wing. So we say, because there are particles, if there are particles, that means there is pressure, because these particles are going to be hitting the sides of its container, or the walls of its container, whatever you want. So these particles that are underneath his wing are hitting its wing. That's what pressure is. And on top, we also have pressure. What is pressure? When particles hit the sides of its container. So look, particles here, we have pressure here. We have pressure acting downwards as well. So how does this bird stay flying? Well, what a bird does, every time it flaps, it gathers up more particles under its wing. Every time it flaps, and that's why the wings are actually, if you look, it's this shape. Because what it does, the bird gathers a lot of particles here under its wing. Meaning, because there's a lot of particles, there's a lot of pressure, because all these particles are hitting the bird's wing, the sides of its container. Remember what pressure is. So there's so much pressure upwards. There's so much pressure that on top, the particles are very few. And so the bird ends up, it's called lift in physics. The bird ends up staying flying. It's being pushed upwards. Well done, Layla. So it stays flying. Does everybody understand how important pressure is? Pressure is just particles hitting the sides of its container. These bird wings here are its container, because they're being contained under the bird's wings. And that's why he keeps doing this, because obviously he loses pressure. Those particles then get spreaded out into the air. So the reason why he's keep doing this is because he's keep gathering particles, so he has enough to keep pushing him up. Pressure. How does an airplane fly? So let's look at a picture of how does the airplane, it has so much weight, doesn't it? An airplane is huge. How does it get into the sky? How does an airplane actually get into the sky? Well, look, you see, if you look at wings of a plane, right? They've got all this stuff underneath. What does that actually do? Well, in this case, it does something else. So I don't want you to think of these little triangle edges there. Oh, let's look at this. Let's look at this picture here from Dreams time. What's happening? Well, when the airplane starts to go and speeds up on the runway, what it's doing as it's speeding up, when it's going, so could you imagine this is the wing of the plane? It's always like shaped like a bird's wing. And it's speeding up, and it's going really fast. And what it's doing is gathering up a lot of particles here, a lot of pressure. It's gathering literally trillions of particles. And all these particles are applying pressure onto its underneath its wing. And there are less particles above. And those particles are also hitting its wing, but with way less pressure. So it keeps doing this. It keeps doing this until it has enough lift. We call this lift in physics. Until it has enough pressure to start flying. And then once it gets in the air, there's a whole other side of physics that we need to talk about. The most important thing here is for you to understand what is pressure. Pressure are particles hitting the sides of its container. So the airplane is going fast enough. It's going really, 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 really fast to gather up all these particles under its wing. So it can what? It can gain enough pressure, enough lift to start getting in the air, basically. Does everybody understand, number one, density, and number two, pressure? Yeah? All right, guys. Haji Ali, I just asked him, what is pressure? And he has a beautiful answer. So I just want to, I've done that off the recording, so I want to record it. Haji Ali, what is pressure?
Pressure is the force made by particles in a specific area.
Exactly. Pressure is just a bunch of particles hitting something in a specific
point.
Yeah, in a specific point.
Yeah.
So here's a question. Do you know what a vacuum is?
Vacuum is a place where there's no particles at all.
So is there any pressure inside a vacuum?
No.
No, exactly. There can't be, can there?
No, there's basically nothing.
There's nothing. And that's an important concept that we're going to use later. Okay? Okay, everybody, before we get into all the formulas that you need to know for this chapter, I think it's important for us to understand the units. So remember earlier I said I will talk about the units. So here we are talking about them. Okay? So temperature is measured in degrees Celsius, which everybody is familiar with, right? So temperature is measured in degrees Celsius or in Kelvin. And I'll talk about the difference between degrees Celsius and Kelvin later. Density, in fact, I really should do this in Bloom. Density is measured in kilograms per meters cubed. Okay? So let me just do that because that looks horrible. So kilograms in meters cubed. Volume is measured in meters cubed. Do you know why that's different? Because remember when we learned like volume back in maths, we always done it like in centimeters cubed, and sometimes the dimensions will be given in meters cubed. Real quick, suppose if I had a, let me do this properly. Suppose if I had a cube, right? It looks like a dodgy cube, but whatever. Usually the edges, so the volume of a cube is, or cuboid, is the width times height times length, right? Length times width times height. I don't know why that took me. Length times width times height. And sometimes the dimensions, most of the time the dimensions were given in centimeters, right? And so when you've done all this, you'd end up getting centimeters cubed when you found the volume. So you're usually used to, when you're looking at volume, and this is important because later on you can mess up in the with exam questions. Usually volume, when you do a lot of math, it's always measured in centimeters cubed. But in physics, for density and pressure, volume is measured in meters cubed. And of course, sometimes in math, you also had the examples where the length will be given in meters. So you have like 3 meters times 5 meters times the height of 2 meters. So you'd end up getting meters cubed. I hope I'm not overcomplicating the situation. Okay? Pressure is measured in pascals. An area is measured in meters squared. Again, in maths, area, most of the time when you do examples, is measured in centimeters squared. And sometimes the dimensions will be given in meters. But you need to know, because you don't mess up in exam questions later, because there's a lot of conversions, and this is how examiners catch you out, is by you not being comfortable with the units. These are the units. So when I tell you density, right, is equal to rho, density, which is rho, is equal to mass over volume, the mass is in kilograms and the volume is in meters cubed. When I tell you pressure is equal to force over area, area is measured in meters squared. So if your question tells you the area is 10 centimeters squared, you're going to have to convert. Okay? What I mean by converting is, look, you need to concentrate here now, okay? Suppose your question, right, 1 centimeter sorry. So please concentrate here. 1 meter is equal to 100 centimeters, right? 1 meter is equal to 100 centimeters. 1 meter squared, 1 meter squared is equal to 100 squared. Because look, you have to square both sides. Okay? So 1 squared is 1 and meter squared is just meter squared. 100 squared is 10,000. So you're going to get 10,000 centimeters squared. Of course, I've taught this a bunch of time in math. So this shouldn't be the barrier to entry here. Okay. All right. So 1 meters cubed. Of course, if you cube this, you're just going to get 1 meters cubed, because 1 cubed is still 1 cubed. 1 cubed is still 1. But if you cube 100, if you put a cube, if you do 100 centimeters cubed, well, 100 cubed is 1,000,000. So 1 meters cubed. Now, this is important to not it's important to not underestimate these conversions, because it can catch you out. 1 meters cubed is equal to 1,000,000 centimeters cubed. And if your math is good, this shouldn't really be your worry right now. So those are the units that we need to do in this chapter. Those are the 2 formulas I have introduced you to so far. I hope this lesson has been of benefit, everybody. I'm just going to end it here.